Hello friends, today we will learn about Python machine learning programming using logistic regression. But today's lesson we will learn how to extract feature. Suppose I am telling you one word, let's say animesh, but machine will not understand any word. You have to put anything in digit. That means 1, 2, 3. You have to put something on numerical digit, otherwise machine will not understand. So if you put any word or something, you have to convert that text into number to convey the message to your machine. So today we'll learn about spam email, how to check. Suppose I'm giving you one mail subject. Based on that mail subject, you have to predict it is spam mail or it is actual mail. Okay. So first make today's heading first. Email spam detection. Okay. So first import all the necessary libraries. Import numpy as np. Import pandas as pd. From sklearn dot model selection. Import train test split. From sklearn dot feature extraction dot text. Import t fid f vectorizer. Then from sklearn import matrix. So first run it. Then I'm going to import my data set. Okay. So I'm taking the data set as mail data equal to pd dot read csv. Since my data set in csv format, that's why I'm doing. Okay, I got one error. Let me check that error. Feature extraction. Okay, my bad. I put m. It will be n. So let me run again. Feature extraction dot text sklearn feature extraction dot text. It will be text. Now it's okay. So mail data. I'm taking my data set as a mail data. So since it is a CSV format, that's why to read that CSV file, I'm using read underscore CSV and it comes under pandas library. Okay. So I'm just putting my path where I have kept my data set. So let me paste that path. After that, let me put my file name. Okay, then CSV, and you have to put R here. Okay, so let's run it. Now let me check the mail data. Okay, this is the mail data. That means you will get the message, and based on that message you will get category as well. If we check the category first, let's check it. So I am checking the value counts. So let's run it. So there are total 5,572 rows are there. Based on that 5,572 rows, 4,825 rows are there where the category is ham, and 747 rows are there where category is spam. So there are two kind of categories are there. One is ham and another is spam. Okay. So first, since ham, spam, these are basically word machine will not understand. So first convert those word into integer. So in that thing I am doing mail data, then replace. Now I am using one is ham. So I am taking ham as 1. So I am using here the dictionary function. Those who are new in this video, they can check my previous video where I can explain all the dictionary function, all those things in details. And I am taking spam as 0. That means I am converting ham and spam to 1 and 0 respectively. And you have to put in place equal to true. So let it run. Ham, okay, it will be like that. Then it will be 1, then this. Okay, now it's good. So let it be done here. Okay. So now if we check the mail data, you will get all the categories 1, 0 respectively. That means previously it was ham, spam, something like that, but now it has converted to 1, 0 something. That means it has converted to numerical number. Okay. Now here is the message. Okay. Again the same thing. Machine will not understand any word or any sentence. You have to convert it to numerical number. Okay, that means any digit, so that machine will understand. So how I will convert that message part into numerical format, that I will come later. So now let's just segregate your data to input and output format. Here our motto is, our aim is, when you will give some message, on the basis of that message, machine will say that it's spam mail or it's ham mail. Okay. So we can take message as input, that means the X variable, and category as output, that means Y variable. Okay. So I'm taking, let me first add some rows here. So I'm taking X equal to, take the mail data, based on that mail data, I'm taking that particular column. So let it run. Okay. Now if you print the X, it will give you only the message. The category will not appear here. Okay. Now I'm taking another variable Y, that is I'm considering as output variable. On that output variable, that means Y, I am taking category. That means I will be replace it by category. So let it be run. Now if you print all the Y value, you will get only 1, 1, 0 something. That means spam, ham, etc., which we converted to 1 or 0 respectively. But here, that means in Y dataset, you will not get anything about message. Okay. So we have segregated our dataset into two format, X and Y. Okay. Now what we do, we know that X data set, okay, this is the X data set, and this X data set contains the message basically, okay. So we have to convert that message to numerical number, otherwise machine will not understand, okay. Before doing that, first I'm segregating, I'm splitting my data set, some of the data for training purpose and some of the data for testing purpose. So to do that, I'm doing xtrain, xtest, ytrain, ytest, train test split x y, test size equal to 0.2. That means I am taking 20% data based on my entire data set. I am taking 20% data for testing purpose and remaining 80% data I will use for training purpose. And random state equal to 3. You can take random state 3, you can take random state 2, you can take random state 4 as well. But if you take different random state, which I have taken, you will get different result if you compare your result with my result. Random state basically how you are going to split your data set. Random state basically reproduce your data set into different way. That means if you take different random state number, your data will be splitted also in different way, okay. So let it be done, okay. So if we print xtrain, so it will be displayed, and if you observe it carefully, it will be in message format, it will not in numerical format. Now if you check it, the x test, again I am going to run, again you will see that it's a message format, it's not a numerical format. Now I'm converting, that means I am extracting some numerical content from this text. In this case, I am taking that feature extraction on mail, okay. Now I will use tfidf vectorizer. Now I will use min, then diff equal to 1. I will explain everything. Then lowercase, I'm taking lowercase as English. You can take other word as well. I'm telling you everything. What is the significance of lowercase, what it is saying basically. First, let me complete. Now I am taking stop words. Stop words I am taking English. Lowercase I am taking true. Lowercase I am taking true. And stop words I am taking English. First, let it be run. Okay, it has run successfully. Now let me explain what it's all about. tfidf vectorizer, and please check the spelling. Here T is capital, after that fid, then again f, then vectorizer, and v is capital. If you put anywhere small, you will get error, okay. So tfid vectorizer we got from, if I just call it up, feature extraction.text. That means tfid vectorizers will convert your text into numerical way. That means the numerical number, okay. To convert the numerical number, first it will search. Suppose I am taking one particular word, let's say I. It will search for the entire data set, that particular word, how much time it has appeared. Minimum appeared should be 1. If any word has appeared less than 1, then it will not consider. To satisfy that condition, I put main diff equal to 1. Now lowercase equal to true. If any word comes in lowercase, that means it's in small letter, not in capital letter, then it will not be ignored. It will be considered. To satisfy that condition, I used lowercase equal to true. Now stop words equal to English. Suppose it is searching in one sentence, but when it will stop, so in that case I put one condition that when it will get any English such type of word, in that case it will be stop it searching. You can put other words as well. You can put trying, you can put since, anything word you can put, and based on that you will get different accuracy of your model as well. So you can do it to get the better accuracy of your model. But here I am using English as my stop words. Now if you observe carefully, X train here, all the messages are in text format. X text here, all the messages are in text format. So you have to convert these messages to numerical. That's why I'm writing X train here I am writing feature equal to feature extraction mel. Since it's a training, that's why we'll use fit transform. Now we'll use X-train and let it be run. Okay, it has successfully completed to run. Now let's check the X-train feature. Let it be done. Let's print it. You are getting all the numerical number. Initially it was text, but now it has converted to numerical number. 0 0.61, 0 0.41, 0 0.4, something like that. 0 0.32, 0 0.22. Okay. The same way, we'll convert the text of X test to numerical number. So in that case, we'll use the same thing. I just have to copy it and I'm going to paste it, but it will be test, not train. X test feature, and X test feature will not fit, will just transform it and change it to X test. Okay, and let it be done. Now let's print it. X test feature, print X test features. So you are getting all the numerical numbers: 0 0.19, 0 0.20, 0 0.25, 0 0.29, etc. So you are not getting any text, you are getting all the numerical number. Okay, so you have segregated your data set, you have converted your text message to numerical number. Okay, now you are going for model. Here let me check one second that logistic regression I have imported or not. No, logistic regression I didn't import it. So let me first import the logistic regression first. So from sklearn dot linear model import logistic regression. Let it be done. Sklearn dot linear model import. Okay, logistic regression. Okay, it will be not like that. Okay, now it's good. Okay, so I'm taking model logistic regression as a model. Okay, so let it be done. Put some rows first. Okay, so model you are taking logistic regression. Okay. Now you are going to fit your model. Model dot fit based on the X trained features. It will be not X train, it will be X train feature, because X train was text data, but X train feature is numerical data. So you have to fit your model based on X train feature, not X train and Y train. Now let's run it. Okay. Now you will predict, we'll do two separate things here. We'll predict our accuracy based on training data, and we'll predict our model accuracy based on testing data, so that we can check that our model is overfitted or underfitted, such type of issue arise or not. If the accuracy of both the cases exact similar, or there is no such deviation between the accuracy which we'll get based on training data and which we'll get based on testing data, there is no such deviation, or I can say small deviation, like one you are getting 90% and another you are getting 88% or 85%, something like that. So in that case, we can say that our model is accurate. It's not underfitted or overfitted. That's why we'll check accuracy based on training data as well as based on testing data. So here, what I'm going to do, I will predict Y train value based on X train feature. That thing I am going to do. So X train predict. I will use model dot predict based on X train feature. So let it be done. Okay. Now we'll do accuracy based on training. Matrix dot accuracy score. This was the measured value, Y train predict, and this was actual value. So accuracy, I am writing it based on, it will be easy to understand, based on training. So let it be done. Now let's print it. So you are getting 96% accuracy based on training data set. Now I am doing same thing, but now I am taking testing data. So first let me copy it and paste here. Now train, I'm just going to replace it with test, and train, I'm just going to replace it by X test feature. Now let's run it. Now again, I'm copying this particular line and I'm pasting it here, and based on testing, here I will use test, and here also I will use test, and let it be done, and let it be predict accuracy based on testing. So accuracy based on training, you are getting 96%, and accuracy based on testing also you are getting 96%. So both the values are exactly similar. So we can say that our designed model giving the good accuracy, and accuracy is 96%. So we can say it's a very good accuracy. So let me just write as an answer, accuracy based on training 96%, 96.70%. Accuracy based on testing 96.59%. So let it be marked down. And so this was today's video. Those who are interested for data set, they can mail me on the mentioned mail ID or can comment in the comment section. I will send the data set. Thank you.